Hi everybody, this is Chapter 11, AP Chemistry, Section 2, Video 2, and we're going to talk about the processes that need to occur in order to make or mix a solution. So really we're trying to answer the question, why does like dissolve like? So to understand like dissolves like, you need to recognize that solution formation occurs in 3 steps. And not necessarily in this order, but the first thing you have to do is to separate the solute. And when we talk about separating the solute, we're talking about separating it into individual components. So for ionic compounds, that's ions. And for covalent compounds, that's molecules. Okay? So you're separating them into individual components. Now this delta H is really the energy associated with that process. So this is the energy associated with spreading out the solute or separating the solute into its individual components. Okay? Delta H2 is spreading the solvent or separating the solvent. The energy associated with spreading out the solvent. Now we know water, when it's a solvent, really loves itself. So it takes a lot of energy to spread apart water because water has hydrogen bonds, which are relatively strong intermolecular forces of attraction. So you have to separate the solvent to make room for the solvent, or solute, excuse me. Oh, did you guys hear the rumor about peanut butter? Never mind, I shouldn't spread it. All right. And this, for water, this requires a lot of energy. This is very difficult to do for water because water loves itself. Okay? And then delta H3 is to allow the solute and solvent to mix. So those are the 3 steps. Spread the solute, spread the solvent, allow them to mix. Those are the 3 steps. So when we talk about the energies for this step, for delta H1, in order to spread the solute, this requires energy. And depending on what solute you have, it may require more energy or less. If the process is energy requiring, then it's endothermic, and delta H will be positive. So for ionic things, this is a very high positive. For polar, this is a very high positive. But for nonpolar, it's not as high. It still requires energy to separate oil, but since the IMFs between nonpolar things are weak, then this is not a very high value, okay? Delta H2, separating the solvent, is also endothermic. It's also energy requiring, so delta H is positive. And again, for both of these, they have for polar and and ionic, it's a large positive, okay? But for nonpolar, it's not so much of a large positive. But delta H3, when they mix, that is an energy releasing, usually, process. That tends to be exothermic. And delta H is negative, okay? And so things in nature tend to happen for one of 2 reasons. They either tend to happen because you're increasing the disorder of the system or you're releasing energy. So if, just to kind of give you an idea while we have this up here, if delta H1 and delta H2 are larger, if it requires more energy than is released when they mix, it's most likely that they will not make a solution. However, if the energy released, if delta H3 is greater than the energy required, then they will make a solution. Okay? So that is why like dissolves like. It really happens to be a sum of these energies. So overall, the delta H of the solution is the sum of delta H1 and delta H2 and delta H3. And if delta H of the solution is negative, then the solute and solvent will mix and form a solution. So really, like dissolves like is really a matter of the energies. If more energy is released when they mix than is required to separate each component, the solution will form. Okay? So here are your 3 steps in pictorial form. This is right from your textbook. Here's step 1, expanding the solute. Again, that energy has to go in to do that. Here's step 2, expanding the solvent. Energy has to go in to do that. And here's step 3, allowing them to mix. And when they mix, here's step 3, if they mix, energy is usually released. And if the energy released when they formed is greater than these, oh, there's step 3 up there, sorry. Energy is released. If that energy is greater than goes in here, then the solution will mix. If not, they won't. Okay? That's the driving force for making a solution. Okay? So what we know with like dissolves like is that polar solutes like sugar or alcohol dissolve best in polar solvents like water. And ammonia. However, nonpolar, I'll write it for you. Nonpolar solutes, like say oil, dissolve best in nonpolar solvents. Like carbon tetrachloride, or another solute could be carbon dioxide. Okay? So nonpolar dissolves best in nonpolar, polar dissolves best in polar. And it's all a matter of those energies. Okay? So this table summarizes or allows you to predict solution formation. If you have a polar solute, then it requires a lot of energy to separate that solute. If you have a polar solvent, it requires a lot of energy to separate that solvent. But they mix together and release a lot of energy. So delta H of the solution will be small but negative and the solution will form. However, if you have a nonpolar solute, those molecules really don't love each other that much. There's not strong IMFs there, so it doesn't require a lot of energy to separate them. A polar solvent does require a lot of energy to separate because polar solvents love each other. And there's not a lot of energy released when you mix the two together. So since the amount of energy released is not enough to overcome the energy required, a solution won't form, etc., etc. All right. So how do you use this information? In reality, use this information to predict solution formation. And who is the best solvent for what particular solute? So this question says, decide whether liquid hexane or liquid methanol is the more appropriate solvent for grease and potassium iodide. Okay? So liquid hexane right here is what we call a hydrocarbon. It's only made of hydrogen and carbon. That's why we call it a hydrocarbon. And hydrocarbons are large nonpolar molecules. And so they have weak forces of attraction between them, okay? Liquid methanol is almost like a hydrocarbon, except it has oxygen in it, right? So the OH bond introduces polarity. This is more polar due to the presence of the OH bond. So this solvent is more polar than this. This is a largely nonpolar solvent. This one's polar. Now, our two solutes we're going to dissolve are this one, C20H42, and that's our solute. And our other solute is Ki. And we have to predict which solvent is best for them. Well, again, if you're mixing nonpolar with nonpolar, that will more likely make a solution than polar with nonpolar. So since this also is a hydrocarbon and is nonpolar, the solvent to use would be the C6H14 because they're both nonpolar and the overall energy associated with that will most likely allow the two to mix. However, this one is ionic. And ionic things mix really well with polar things. They release a lot of energy when they mix. Ionic things dissolve best in a more polar solvent. So the best solvent for this one is the methanol due to the OH presence introducing a degree of polarity. Okay? Next week, I guess it's Tuesday, we'll talk more about other factors other than polarity that affect whether or not a solute dissolves. But that's it for today. Don't forget over the weekend to finish your test corrections and do those questions. I think it's 24 through 27 or whatever it is, assignment number 1.
And don't do drugs.
And don't do drugs. Stay safe and stay off the streets. Have a good weekend, everybody. We'll see you. Bye-bye.